A new AI data center can require a gigawatt of power, but that number doesn't tell you how much of that power can actually reach the computers. A power plant somewhere on the grid might have enough generation capacity. The problem is getting that electricity to one particular place. The transmission network may not have enough capacity, a substation may need to be expanded, new equipment may have to be installed, and connecting a massive new data center to the grid can take years to plan and build. So the location of an AI data center is becoming a very different kind of decision. Cheap land is useful, but land with access to large amounts of reliable electricity can be much more valuable. And even after the power reaches the site, the physical problems continue. AI servers are unusually power dense. Thousands of GPUs can operate in a relatively small space, drawing enormous amounts of electricity at the same time. Almost all of that electricity eventually becomes heat. As more computing is packed into each rack, removing that heat becomes harder. That's why cooling is becoming a much bigger part of data center design. Liquid cooling can move heat away from high-density computing more efficiently than traditional air cooling. But it also changes the infrastructure around the servers, requiring pumps, heat exchangers, plumbing, and other equipment. The computer itself may not look very different. The building around it does. AI data centers don't necessarily draw power in a perfectly steady way. Large clusters can change their electricity demand as workloads start, stop, or shift. For the grid, that matters. Electricity supply and demand have to stay balanced from moment to moment. A very large load that changes quickly is different from one that stays relatively constant. So the challenge isn't only how much electricity an AI facility uses, it's also how that demand changes over time. Some large projects are being designed with their own generation or energy storage. Others are looking at microgrids that can give a facility more control over where its power comes from and how it responds when the grid is under stress. At a certain scale, a data center starts looking less like a building that happens to contain computers and more like an industrial energy project. Some AI workloads don't have to run at one exact moment. A real-time application obviously can't wait, but model training, data processing, and other large computing jobs can sometimes be scheduled differently. That means some computing could potentially move to a different time or even a different location when electricity is scarce. Researchers have already tested this idea with GPU clusters, reducing power consumption in response to grid conditions while continuing to meet computing requirements. Google has also been working with utilities on demand response programs that make some data center workloads more flexible. When the grid is under pressure, certain computing jobs can slow down, move, or wait. When more electricity is available, those workloads can run. Instead of simply taking whatever power the grid provides, some data centers could eventually respond to the grid. But that possibility doesn't change the larger problem. AI computing is expanding faster than the physical infrastructure needed to support it. Software can improve quickly. A new model can be trained and deployed in months. Physical infrastructure moves at a different speed. A transmission line can't be built with a software update. A substation can't be expanded overnight. And a new source of electricity can't simply appear because a data center is ready for it. That difference in speed may become one of the biggest constraints on AI's expansion. The question for the next decade may not simply be how powerful a computer can become. It may be how much computing the world around it can support. The AI boom started as a software story, then it became a chip story. Now it is becoming an infrastructure story as well. And every new AI gigawatt depends on a much larger physical system that most people never see.